All right, this video is going to be going over two sample means tests where we don't know the population standard deviation. The average amount of time boys and girls in ages 7 to 11 spend playing sports is believed to be the same. They collect some data here, and we're going to assume that each population has a normal distribution. And I believe this problem wants us to test that claim. So we're going to run a two-tailed test to say, is it the same or is it not the same? Okay, so because I have two independent samples here based on girls and boys, I'm going to define two different means. So let's maybe call this mu g for the true average or true mean, it doesn't matter, amount of time girls 7 to 11 spend playing sports each day. And we'll say mu b is the true average amount of time boys 7 to 11, and same thing there. All right, this is trying to say that they are the same or that their difference is 0. And we're going to test that claim or try to say that they are minus, the difference is not 0. Okay, so let's go ahead and set up our distribution here. Now I am going to have to use a t distribution because I'm using S to approximate the population standard deviations. Also, the n's are really, really small, but the populations are known to be normal, so it's going to be okay to move on with this. And it does not give me an alpha level in this problem, so we're just going to default to alpha being 0.05. And since this is a two-tailed test, I'm going to split that up so that alpha over 2, or 0.025, is on each side. So that's my rejection region. And so I have three options. I have two critical values. It's going to end up being, my critical values are at plus or minus 1.96. Oh, no, we have to look at degrees of freedom. That is not true. I'm going to use StatCrunch in order to do that. Degrees of freedom for 2 sample is like, it's a really, really yucky equation. So we're going to use StatCrunch in order to find that. But it is not 1.96, that would be for the z. I need to go in and use that. But I have a couple different options, right, in order for this to be. I might be in this region, I might be in the middle region, I might be down here. So I need to figure out like what region x bar girls minus x bar boys. It could be in any of these three. So I got to figure out which one I'm in. All right, I'm going to come back up here to the table so that I can plug this into StatCrunch here. So I'm going to go to Stat. I'm going to do t-test, a 2 sample, and I'm going to do that with the summary. Sample mean for my first one is 2 and then 0.866. So 2.866, and I think there were 9, right? Yeah, 9. Okay, and then for boys, 3.2. Is that correct? 3.2. I remember. Okay, 3.2. Standard deviation of 1, and there were 16 of them. All of this looks good. Don't worry about pooling all of that. Like that's like a higher level thing. So just leave that off. That's okay. I do want to run this hypothesis test, show that critical value, and it will calculate degrees of freedom and give me that confidence or critical value, excuse me. Okay, so see here, see how our degrees of freedom aren't perfect. It uses this really complicated formula in order to find the degrees of freedom. Our critical value is plus or minus 2.09. And it looks like our T, degrees of freedom, were about, let's say, like approximately 18. Okay. And so it looks like in our output here, our T statistic is negative 3.14. So T there we go. Negative 3.14, which means I am in this region here, right? I'm smaller than negative 2.9. And what was our p-value? It should be pretty low here, 0.0054. Which is going to be less than the alpha level of 0.05, right? All right, so we get to reject HO. There is significant evidence that playtime for girls and boys is not the same. Okay, and that would be our answer.